In this lesson, we're going to look at how to prove trigonometric identities. So being able to manipulate trigonometric expressions is an important skill that's used to solve trigonometric equations, differentiate trigonometric functions, and integrate trigonometric functions. At present, these are all the current identities we know. So in C2, we learnt that tan theta is sine theta over cos theta. We have these new expressions, identities here, in fact, that we've learnt in C3. This Pythagorean identity we learnt in C2, and these new ones underneath here as well have come from C3. And so it's good to have these as a reference just to look at and identify when we need to use them. So this can be a tricky thing. There's no set method to do this. It requires your thinking to have a go at it. So it says in this question, let's prove the identity tan squared theta equals sine squared theta equals sec theta times sec theta plus cos theta times sec theta minus cos theta. Just note that this I will refer as the left hand side, this I will refer to as the right hand side. Now when I try to prove identities, the way I go about this is that I try to identify a side where there looks like some sort of operations to perform. And on the right hand side here I can see that I can expand the brackets. So if I just write out expanding the brackets, sec theta times sec theta is sec squared theta. Sec theta times minus cos theta is minus sec theta cos theta. Cos theta times sec theta is plus sec theta cos theta. And then cos theta times minus cos theta is minus cos squared theta. If I tidy this up, the right hand side is equal to sec squared theta minus cos squared theta. At this point there's no more operations that I can see to do, but if I look at my left hand side, what I notice is that I need a tan squared and I need a sine squared. Now what I know from the Pythagorean identities is I know cos squared theta plus sine squared theta equals 1. So in fact cos theta equals 1 minus sine squared. So that could help me work towards the sine squared. I also know from the Pythagorean identities that we have 1 plus tan squared theta equals sec squared theta. And this will help me remove the sec squared theta and move closer to the tan squared theta. So let's make those substitutions. The right hand side now becomes equal to 1 plus tan squared theta minus 1 minus sine squared theta. And so at this point we should notice that 1 minus 1 cancels out, tan squared is left on its own, and then I get minus sine squared theta, so I get plus sine squared theta. And so what I've done, I've shown that the left hand side is equal to the right hand side. Okay, so it may not appear obvious what to do at first, but you just have to kind of follow instincts, go for where there's some sort of operation, algebraic operation that can be performed if necessary, and then look for substitutions. Let's have a look at the second example. Prove the identity that cot to the power of 4 theta plus cot to the power of 2 theta is equal to cosec to the power of 4 theta minus cosec squared theta. Okay, so when approaching this question, remember that this will be the left hand side and this will be the right hand side. So I'm going to start off, I'm actually going to factorise. I will work with the right hand side here. I'm going to factorise the left hand side. So the right hand side, I'm going to factorise the right hand side. So this becomes now cosec squared theta is 1 leaves inside the bracket. Sorry, I'm skipping ahead there, I'm not factorising correctly. Cosec squared theta minus 1. Okay, so there's not much I can do else here. I could have factorised the left-hand side, and that's a different approach to do. At this point, it's worth noting that I know that cot squared theta plus 1 equals cosec squared theta. And also that this can be rearranged so that I get cot, not cost, but cot, it's a bad habit of mine, cot squared theta is equal to cosec squared theta minus 1. And what I can do in this case is I can get rid of this cosec squared theta for cot squared theta plus 1. And I can also substitute out cosec squared theta. Let's make sure I've got that plus 1, that's a little bit ambiguous. I can also substitute out the cosec squared theta minus 1 because that is equal to cot squared theta. Having done those substitutions, if I expand those brackets, I get cot to the power of 4 theta plus cot squared theta, and so therefore I have shown that the left hand side is in fact equal to the right hand side. Okay, let's have a look at one more example. This is by far the most challenging one. I want to prove the identity that the square root of 1 over cos theta over 1 minus cos theta over 1 plus cos theta is equal to cosec theta minus cot theta. Again, this is referred to as my left-hand side. This is my right-hand side. There's no apparent way to start off with this, so I'm just going to start off with the left-hand side of my right-hand side of this identity. And what I'm going to use is I'm going to use that I know that cosec theta is 1 over sine theta. And I'm going to use that cot theta equals cos theta over sine theta. So remember, it's 1 over tan theta, so I've just inverted the definition of tan with sine over cos. Okay, so now what I get then in that case is that the right hand side is 1 over sine theta minus cos over sine theta. And so I know with the same denominator I can simplify this into one fraction. So I get 1 minus cos theta over sine theta. Now, this is a step that may not appear obvious at the moment. The problem I've got is I'm kind of getting close to this, but I've got no square root. So what I'm going to do is I'm going to square root both sides, and I'm going to square both sides. That means I'm doing inverse operations on both sides, and so it means I haven't changed, on this object here, that means I haven't actually changed it, but it does get me that square root, so I get 1 minus cos theta squared over sine squared theta. And what I've done is I've just squared the top and bottom. So if I did the square root of the top and bottom, I'm straight back to where I was a moment ago. Now, if I use that the cos squared theta plus sine squared theta equals 1, the original Pythagorean identity, and rewrite this as sine squared theta equals 1 minus cos squared theta, then I can rewrite this right hand side. First of all, I'm going to rewrite the top as 1 minus cos theta times 1 minus cos theta, because that's what 1 minus cos theta squared means. Underneath, I'm going to write 1 minus cos squared theta. It's not obvious why I do this at first, but now, my right hand side, if I notice the bottom of my fraction here, it's actually a difference of 2 squares, so I can factorise that as well. So I get 1 minus cos theta times 1 minus cos theta over 1 minus cos theta times 1 plus cos theta. And the whole point of this now is, as hopefully you can see, I can cancel the 1 minus cos thetas, top and bottom. so that I get the right hand side is equal to the square root of 1 minus cos theta over 1 plus cos theta. And so I have shown then that the left hand side is in fact equal to the right hand side. Now this last problem is quite challenging. It takes quite a bit of experience to get to this point, but what I wanted to do was I wanted to show you a range of identities to prove, to show from some of the simpler ones to some of the more difficult ones. Being able to work with some of the more difficult ones like this just comes from experience, and so the more problems you try, the more experience you get, the more tricks and techniques that you get into your kind of like little armory of skills that you can use to approach this problem.